Hey guys, it's Landon Blake from topbysurveyor.org. This is our very first video that we're doing that's going to really get into some actual math. Are you excited? I'm excited. Alright, so what are we talking about in this first video? We are going to talk about types of numbers. Okay, now, I know I promised you I was going to show you some practical application of math so you could learn how math is going to be a tool, and I'm going to do that, okay, but I'm going to have a set of videos that just cover some basic arithmetic, right? And you need to make it through those videos so that you can get to some of the stuff that's a little more enjoyable, or actually show you how surveyors use math as a tool, okay? So hang in there, don't give up, okay? I got a few videos. I'm going to do this one. I'm going to do a video on fractions. I'm going to do a video on unit systems and rounding. I know you're falling asleep. It's really boring. But we got to get through, I might do 1 or 2 basic algebra videos before we get to some fun stuff, okay? But hang in there. So this video is going to put you to sleep. Grab a cup of coffee, take a 5-hour energy shot. All right, it's going to be short. We're going to get it through it. Now, I will tell you in this video, we are going to talk a little bit about some computer programming. So that's kind of cool because I want to teach you guys math while I teach you computer programming. We're going to use Python, which is a really cool, easy language. I'm going to show you guys how to use that on the desktop. And we're going to actually apply some of what we're learning from this first video in Python, which I think is cool. All right, so I know math is boring, but bear with me. Okay, types of numbers. We're just going to talk about a few different types of numbers, okay? So I don't know if you know this, but numbers have types, right? Just like people have types of jobs. It could be a doctor or a lawyer or a land surveyor. You have types of numbers, all right? So the first type of numbers that we have are whole numbers, okay? And a whole number is just a number that doesn't have a fractional part, okay? And so the fancy term for that, mathematicians call these integers, okay? But they're just whole numbers. And you're going to see as we go through these videos that mathematicians like to come up with hard names for stuff because mathematicians like to make math hard. And so we're just not going to do that. We're just not going to play their game. So we're going to call them whole numbers because that's what they are. But mathematicians call them integers. And you need to know this because when you're working in a computer programming language, programmers are like mathematicians. They like to make stuff hard too. So guess what? That's what programmers call whole numbers. Okay, so whole numbers are integers. They're just numbers that don't have a decimal part. So let's look at an example over here. Okay, I'm going to draw above this line a whole number, the number 2, one of my favorite numbers. It's a whole number. There's no fractional part, right? And let's do 777. That is also a whole number. There's no fractional part. There's no decimal point. There's no little piece, right? That is a whole number. Okay, now whole numbers can be even or odd, right? So even means it's evenly divided by 2. Okay, odd means if you divide it by 2, you're going to get some fractional part. Okay, we're not going to get into a whole bunch of detail about that, but you can have whole numbers can be either even or odd. Okay. Okay, then we have what I call decimal numbers or numbers with a fractional part. Okay, and mathematicians and computer programmers call these floating point numbers. And I'll explain why that is. It has to do with the way we store numbers in computers. Okay, and the reason they call them floating point numbers is because those numbers kind of float around a little bit. And it all has to do with how we store numbers in a computer. And I'll explain that probably in a different video. Okay, but we got decimal numbers, so let's look at an example of some decimal numbers, okay? 2.021, okay, that's a decimal number. 777.45, that's a decimal number, okay? So those are both decimal numbers, right? And I should mention now, before we move on to the tricky stuff, that numbers can be positive or negative, okay? So, and we're going to do another video on a number line, and this will make more sense, but positive numbers, you have a little plus sign, negative numbers, you have a minus. We don't usually write the plus sign on positive numbers. Okay. So whole numbers, decimal numbers, that's numbers with this is what I call this piece over here. Let me get a different color. This little piece right here on the right side of the decimal is what I call the fractional part. Okay. The piece over here on the left side of the decimal, that's the whole number part. Okay, so these are decimal numbers because they have a fractional part. They got a little piece on the right side of the decimal. Now there's a question some people ask, well, hey, is 2.000 a decimal number? It's kind of a tricky question. We're going to talk about in another video about rounding and scale and precision, and we'll come back and significant digits, and we'll talk more about this, but don't worry about it for right now. This is hard enough. Okay, unending numbers. Those are special numbers, so a lot of people might not know this, but math has some special numbers. It has some special numbers that don't end. Okay, I call these unending numbers. Mathematicians like to call these, I think they call them irrational numbers. Don't quote me on that. Okay. But they're just numbers that don't end. And so I'll give you some examples. So pi is an example of a number that doesn't end. Pi. Okay, and I usually remember pi to just 2 decimal places because my brain's not very big. Okay, 3.14, but there's a bunch of other digits to pi, and those digits go on forever. Okay, so we call those unending numbers. There's another number because we work in what we call a decimal system, which means 10, right? So you have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you start combining digits to represent bigger numbers. That's called a base 10 system. Okay, in a base 10 system or a decimal system, you can't always exactly represent certain numbers. Okay, and that gets tricky, and we got to deal with that. We got to deal with it when we're in computers, and we also have to deal with it in surveying. Okay, so I want to give you a quick example. We'll do another video, probably the rounding video. We'll talk about that, but let me just give you an example. If you want 1/3, that's a fraction. We're going to do other videos on fraction. You can't represent that exactly in the decimal system, so you end up with an unending number. Okay, so it's 0.3333333333. These threes keep going on forever. Okay, that's an unending number. Now, most mathematicians, when they write that, so if they have an unending number like this, they put a little line over the last digit. That means it keeps going forever. 2/3 is another one, so this is how 2/3 would look. Okay, but I think that's silly. Who came up with that system? I don't know. I think they should just make this a little arrow so that you know that it goes on forever. But, mathematicians like to make stuff hard. So those are unending numbers, and there's a whole bunch of them, right? So I would call these regular unending numbers because because we're trying to represent fractions in a decimal system, a base 10 system. Okay, these numbers like pi are special. These are special. I'm going to put it in quotes and give it a star. Okay, pi is a special number. There's another special number called e. E goes on forever. That's a special number. So there's a certain set of special numbers in math, special unending numbers. Okay, here's the important thing to remember about unending numbers for programming, and we'll get into this when we get into Python. You can't represent an unending number with perfect accuracy using the method that computers usually use to store numbers. So you have to do something that's called a function or an algorithm, and then you got to tell the computer how many digits you want to compute that. So I want to go 10 digits or 100 digits or 1,000 digits, right? 1,000 places past the decimal. So we have to use a function for these, where decimals and whole numbers we can store in what's called a variable. That's just a bucket that holds a piece of data. Okay, and I'll get into that some more. We'll get into that some more when we do Python, and we might even write a little program that calculates unending numbers. Okay. I don't know if we'll do one for pi because I might not be that smart, but we'll do some other ones, and I'll show you guys how we can represent that number with a function. Okay. So then the last 2 numbers are kind of special numbers. One is what they call imaginary numbers, and that's because when you work with square roots, and I won't get into a bunch of details, but when you take any negative number times itself, so -3 times -4, you always get a positive number, so that's positive 12. And so what they needed to know is they needed a way to multiply 2 negative numbers together and get a negative number. Okay, and they didn't have a number that did that, so they just made one up. Well, that's kind of cool. If you're a mathematician, you get to do that. I wish I could do that in land surveying. There's no easy answer. I'll just make one up. But that's what mathematicians get to do. So they made up a number. It's called little I. Okay, and it's an imaginary number, and a little I is equal to the square root of -1. So if you take little I times little I, you get -1. So those are imaginary numbers. I don't know that I'm going to do anything with imaginary numbers. Surveyors don't really use imaginary numbers, but I just want to let you know. Then they have this thing called complex numbers, and I'm probably not going to do anything with that. Surveyors don't use complex numbers on a daily basis either. And then, I don't know, maybe there's other types of numbers hiding out there. Maybe there's a type of number that hasn't been discovered yet. Maybe you're the next person that just makes up a type of number. I don't know. Could be. Maybe my videos inspire you to do that. But if you know other types of numbers that I've missed, let me know in the comments. Maybe I'll do a little research on them and talk about them. Okay? So these are the different types of numbers. These are the 3 important types of numbers for surveyors. Whole numbers, decimal numbers, unending numbers, and we're going to show you how you store those different types of numbers in Python. I'll do a video on that. All right, cool. We got the examples over here. Don't forget, we're going to talk a lot more about significant digits and rounding and, you know, how you handle unending numbers and survey calculations, because that's important. Okay, but so there it is. There's the first taught by a surveyor math video where we talked about all the different types of numbers that you've got. Thanks for watching.